Hello. So welcome back. So we're going to talk about the natural language processing. So what is the language processing? So natural language processing is a field in computer science, in artificial intelligence. Also, in within the branch of artificial intelligence, we have what we call machine learning, and it's focused on linguistic concerns with the interaction between the computer and the human natural language. So specifically, the process of computer extracting meaningful information from natural language input or producing natural language output. So what does that mean? It's practically the computer being able to take a human language and be able to understand it, and then being able to so what it does, it takes an input information, right? The natural language, which is the humans, right? Humans' natural language. It takes that as an input, process it, and then it returns it back, right? So then it can create complete sentences. So the human, so then so there's like the communication between the computer, the human, and then throwing it back, right? So we can actually see a lot of that with Siri, right? Listening to our language, right? To our us talking to Siri or Alexa, and then processing those words and understanding it, and then returning and then replying back to us. Also, we see it with ChatGPT when we ask them questions. It takes what we have written on the ChatGPT. It processes the information by, extracting words and separating them into categories, and then analyze it, and then returns back by making new sentences back to us, right? So that is what is the study of natural language processing. And so a lot of the trends that we have for the natural language projects, like I said, ChatGPT, Alexa, Siri, but so the internet is a huge and easily accessible resource of information. We have a ton of data collected every day. Um, but the problem is that most of this data is unstructured. So usually doing a process of scrapping is sufficient to do it, but sometimes it's not. So the natural language process solves or helps in converting free text, which is the unstructured information, and turn it into a structural form. So we're going to talk about how we can categorize this and separate it into different structure into a structure. Some of these goals, right? Some of these tools are called cleanup, tokenization, stemming, lemmatization, part of speech tagging, query expansion, synthesis segmentation, information extraction, name entity recognition, sentiment analysis, word synthesis, word sense disambiguation, text similarity, machine translation, automatic summarization, natural language generation, and there's even more. So, and that evolves from linguistics, written, reading, hearing, everything displaying. So there is a lot more options, a lot more goals where we can improve this. That can help us improve the natural language processing. We usually refer to the words as a term. A document is practically what we refer to as an entity, a unit, or an object, and so a terms are practically features of the document. We'll go specifically more what a term could be represented, but each term has properties like normalization, normalized form, term-based form, plus the like a normalization form is practically a term-based form plus a term transformation. Position in the documentation is found by the term that position. Frequency is determined by the term frequency. So normalizing the form is practically restructuring the word into a specific way that is readable. Position is practically where is the position in the document, and then we have frequency. How often does a word appear or term appear in the document? So what is the document? Like I said, right, is where we actually have a bunch of phrases or sentences in like a file, right? A text segmentation is the process of dividing written text into meaningful units, such as words, sentences, or topics, right? So when we segmented a text, we're practically just dividing it into meaningful units. It could be words, sentences, or topics. In general, we separate them by terms, but we wanted to think about it that you separate into words, sentences, and topics. It's a hard problem to consider. We consider the whole document as one entity. Stemming, the process of stemming is reducing inflected words to their stem, base, or root form. For example, car in cars, the stem word is car. Run, ran, running, the stem word is run. Stemmer, stemming, stem, the stem word is stem. So what we do is we take a word that that is that it might be conjugated or might have some additional not value, but additional words that might influence some emotion of it, and reduce it into the basic or original word, which is the stem, what we call the stem. Terms and features. What we wanted to do is we want to convert words into terms. The term frequency is usually the most important feature. How to get the list of terms with frequency. Frequency is how many times does the term appear in a document. Pre-processing is to remove all but words, remove stop words, tokenization, rejects. So word normalization means that we practically just refer to our simplest form of our word. For example, dog and dogs, Celino and Naj Zelensky. And we can use this by using already built-in tools from a string, like to lower, rejects, stemming, lemmatization, and much harder for inflectional languages like Croatian. So sometimes, like some other languages, that might be a little bit harder to do, like Croatian, a Croatian language. Like I mentioned before, the frequency of a term is how much does it actually appear in the document. And so there's something called the term weight, which refers to the term frequency inverse document frequency. So it has a couple variables, the T term, the D, which represents to one document, the capital D, which represents all documents. So TF is the term frequency in a document function. It measures how much information the term brings in one document. The inverse document frequency of the term function, in other words, the inverse measure of how much information the term brings in all documents. So the term weight refers to the term frequency, and the inverse document frequency. So it's how much information does it actually bring the term in the document. Term position and syntax. Sometimes term position is important. The words that are around the terms that are around the term that we're looking at is also important. Neighbors, collocations, like where is it set up in the where's the sentence set up in the where's the term, the word set up in the sentence. That makes a big difference. The phrase extraction, from rejects to parsers. Also the syntax trees, and which we're going to be able to see an example, and the complex CPU intensive. So here is a sentence that says, in their public lectures, they have even claimed that the only evidence of Khufu built the pyramid is the graffiti found in the 5 chambers. Now, what we can do here is we can take this sentence and plug it into a tree. And as you can see, the different hierarchies in the trees will set up the level of our words. Now, every word is going to be in a leaf of the tree, not within the interior nodes. So it's always going to be uh, the outer nodes, which are called the leaves. So you can see the in right there in the beginning there, public. Let me so you can see here in, oops, that one. So you see in their public lectures, they have even claimed. Okay, so words that are usually more frequent will be closer to the root. Letters that are lower, that are not as frequent, will go down. So that's practically how you want to be able to set up. Is you usually have a level on where the each word is going to land, and the closer to the root the letter or the term, the better will be. And the reason that it's better is because you have a quickness in your accessibility of the processing the letters, the words. Sorry. Simplify an effective way to process document by disregarding the grammar. In other words, the term-based form, disregarding the word order, the term position, and the keeping only the multiplicity term frequency. So these are some of the tools that will make our process much more simple and effective when handling it. Right. So machine learning. So natural language processing is one of the applications of machine learning. After the text is converted to entities with features, machine learning techniques can be applied. So you have to do practically a cleanup of the data, make sure that it's well set up so that it can be implemented into the model. Machine learning algorithm familiarity categorization. So there's two main ways of processing a artificial intelligence. Um, one of them is supervised. Sorry, let me talk about machine learning instead of yeah. So There's two different, mainly two different tools that we can use to be able to categorize our data. One of them is supervised, which is a way to classify, in other words, distinct elements. Regression, which is numerical continuous, or a unsupervised. So in the supervised, we're actually training the data, but we're also providing them the correct solutions, telling them that that this is the right solution, and then we'll make adjustments according to that. Now, the unsupervised, which is mainly done for clustering, what it does is that it doesn't need to have 1, 2, 3 steps in order to be able to do that. All you need to do it's for the unsupervised uh, unsupervised is that for the supervised you need the correct solution target to be able to make sure that it's correct. If you don't have a supervised a supervised if you have an unsupervised machine learning, then you don't need to provide the target values. It would learn itself. It will make different clusters. A lot of the various methods, algorithm familiarity, statistical probability, a lot of the various methods, algorithms, families like statistical probability are very important. The decision trees are also helpful when we do machine learning, like we saw the tree. The neural networks, deep learning, support vector machines, we talked about that. The Bayesian networks and the Markov models, genetic algorithms. Here are some examples of how machine learning can be implemented: classification, clustering, dimensional reduction, and regression. So they're all different types of machine learning. So we talked about the k-means already. We talked about the k-means. Trying to find my pen. So you can see here, we're talking about the k neighbors. K neighbors, k means. We talked about that, and yeah. Some other methods that we can use for natural language processing is the naive bias, the Markov models, the support vector machine, the neural network deep learning. And some of the libraries that we might use for natural language processing is strip, split, join iterators, and that's specifically for the string. And for the regex, not only match but transformation extractions, back references, etc. Use the read options, read multiline, REPL can be function. The definition of REPL, we can define that, and then the pattern replicate string. And then again, to give us a revise of what we have done in class, we talked about classification, regression, clustering, pre-processing, model selection, and dimensional reduction. We haven't done dimensional reduction, but classification and regression and clustering is practically how you define your model. Classification means that it's a discrete. Regression means that it's a continuous value. So regression, you will be able to have something like the that is a continuous data. Classification would be a discrete data. But anyway, so that's the end of the lesson. We'll stop and go to the next one.